Welcome back everyone. We will be discussing about oogenesis and folliculogenesis. So let's start. So this photograph I have taken from Spirov, and we can see here the purple one, it is the oogonia, and the red one, it is the oocytes. So maximum number of oocyte is reached about 6 to 8 million by 16 to 20 weeks of gestation. Rapid depletion occurs before birth, resulting in 2 million oocytes at birth and 3 lakhs at puberty. We can see here, these one are important, that at birth there are 2 million, by puberty 3 lakh, by 35 years there are 25,000 left, and by menopause only 1,000 are left. These three figures are important. Completion to diplotin stage, it happens by birth. Completion of first meiotic division, it happens just before ovulation. And completion of second meiotic division is at the time of fertilization. When sperm enters the oocyte, then only the second meiotic division happens. Before that, the oocyte is arrested in metaphase 2. That's why it is known as M2 oocyte. Coming on to folliculogenesis, factors responsible for initial recruitment and formation of primary follicle is known as folliculogenesis. So there are some activators and there are some inhibitors. So activators are the KIT ligand, GDF9 and the FGF2 bone morphogenetic protein. These all are activators, while inhibitor, the most important inhibitor is AMH. We all know that. Let's discuss about the folliculogenesis, how it happens. So we can see here, this is the ovary, and folliculogenesis, it happens within the cortex of the ovary. This outer one is the cortex and the inner one is the medulla, and these vessels we can see, they are the hilum. So the goal is to produce a single dominant follicle from the pool of growing follicles. 4 major regulatory events are involved in this process of folliculogenesis. First is the recruitment, because there are at time a lot of follicles are there in the ovary. So out of those follicles, the only single dominant follicle, or at the max 2 follicles, they are selected. And out of those, the pre-antral follicle development and then selection, that which follicle is the best follicle for the further dominant follicle formation happens. And finally, all other follicles, they undergo atresia. So that is what the basis of folliculogenesis. Folliculogenesis is divided into 3 phases. One is gonadotropin independent, responsive and dependent. Gonadotropin independent means the follicles are not under the control of FSH. Gonadotropin responsive means the follicle starts getting the FSH receptors, but still the FSH is not, they are not dependent on FSH. FSH presence or its absence does not lead to follicle atresia or does not lead to growth of them. While follicular dependent means if FSH is supplied, the follicle starts growing up. And if FSH is withdrawn, the follicle atresia will happen. So, gonadotropin dependent phase starts once the interim formation starts happening. There are 8 classes of growing follicles, broadly divided into 2: pre-antral, before the interim formations; antral, after the interim formation. It takes more than 300 days for a recruited primordial follicle to grow and develop into a class 2 or 3 or cavitation stage follicle. The time interval between interim formation and development of 20 mm pre-ovulatory follicle is about 50 days. Around 15 to 20 days are required for a dominant follicle to grow and develop to the pre-ovulatory stage. An interesting fact is, in each menstrual cycle, the dominant follicle that ovulates originates from a primordial follicle that was recruited almost 1 year earlier. So, in a nutshell, folliculogenesis, it starts with the primordial follicle. Primordial follicles are flat granulosa cells. primary follicle, these flat granulosa cells get converted into cuboidal to columnar cells. Secondary follicle, multiple layer of granulosa cells. Preantral follicle, the theca cell layer comes into being, and the antral follicle, we can see the cavity formation. So the primordial follicle, it consists of we can see here the oocyte, which is arrested in diplotin stage of meiotic prophase, surrounded by a single layer of spindle-shaped granulosa cells. Primary follicle, when the quiescent primordial follicle is activated to grow, the granulosa cell, they increase in number, we can see here, and change to cuboidal cells. Coming on to gap junctions, the granulosa cells are avascular. The basal lamina works as a blood follicle barrier. Granulosa cells send processes through zona layer and form the gap junctions. Gap junctions are composed of connexin protein, which play important role in follicular development. Gap junctions are upregulated by FSH but downregulated by LH. They are essential for growth and multiplication of granulosa cells and for nutrition and regulation of oocyte. Post-ovulation, the gap junctions are important for corpus luteum and are regulated by oxytocin. So what we got from this slide, that before ovulation it is the FSH and LH which are maintaining the gap junctions, but post-ovulation it is the oxytocin which is maintaining the gap junctions. Secondary follicle, the transition from primary to secondary follicle, there is acquisition of 2 or more layers of granulosa cells. Tertiary follicle, it contains oocyte, we can see here the oocyte, and which is surrounded by zona pellucida. This pink one is the zona pellucida. 6 to 9 layers of granulosa cells. Basal lamina, we can see here, these are the all granulosa cells. And there is theca interna and theca externa. The outer, this is the theca interna, this one it is labeled, and the outer one are the theca externa. And there is appearance of the antrum. We can see here, this is the antrum. Again, we can see there is antrum. So I hope this was helpful because oogenesis and folliculogenesis, they are important to form the basis of the further reproductive medicine. So that's why all these topics, although they are boring, I have covered them. Thank you.